Hi, I'm Ms. Vung, and today we're going to look at tangents and normals. If f is differentiable at a point, x1, then the equation of the tangent at that point, x1, y1, is given by this linear equation. You've seen this in year 7 and 8. Y minus y1 equals gradient x minus x1. But we've also seen that the gradient can be written as f dash x, the derivative of the function f of x. So we can substitute that gradient over there. So this is a linear equation for the tangent. What about the normal? Now we know the gradient of the normal is minus 1 over m, because that's the gradient. Then we can write it as minus 1 over f dash x. So the equation of the normal will be exactly the same, with the gradient being minus 1 over the derivative. We're going to be using these two equations for the following examples. So find the equation of the tangent to x to the power 2/3 at x equals 1. So the three steps for these types of questions to find the equation, that's the final step, is to first obtain a point and then find the gradient. So for the point, we use the original equation, substitute x equals 1 to find the y value. So when x is 1, 1 to the 2/3 is just 1. So our point is 1, 1. Next, we're going to find the gradient, the derivative at 1. So first, the derivative. To derive that, 2 over 3 goes to the front, and then 2/3 minus 1 is minus 1/3. Now at 1, substituting 1 in, we have 2/3 times 1 is just 2/3. So that's the gradient. We have a point, we have a gradient, put into the linear equation, we have y minus 1, 2/3 x minus 1, and rearrange to obtain that linear equation. So that's a tangent at x equals 1 to that function. Let's try another example. This time I'm not going to put the 3 boxes, and we can do it more like you would do it in your exercise books. So again, find the point by substituting the value into the original equation. So putting 0 in there, we have minus 1 to a third, which is minus 1 because it's odd. Then we're going to derive it using the chain rule. So x becomes 1 times a third, x minus 1, and then a third minus 1 is minus 2/3. Now the derivative at 0, so this at 0, minus 1 to the negative 2/3. Oof, it's just a mouthful. So minus 1 squared is positive. And then cube root that, well, it's still positive, so we just have a third. So gradient, we have a point, put into y2 minus y1, sorry, y minus y1, gradient x minus x1. So putting this point in, that's x, that's y, and a third. We have y equals a third x minus 1. Example 3, find the equation of the tangent to y equals 1 minus cos x, where x is pi and 2. Again, let's start with the y value, or the coordinates. So when x is pi and 2, putting into the original equation, we have 1 minus cos pi and 2. Pi and 2 is 0, pi and 2, cos up there is 0, so we're left with just 1. Next, we look for the gradient. So deriving that, 1 disappears. Cos x becomes minus sine x. So minus cos x becomes positive sine x. The gradient at pi and 2 is sine of pi and 2 is 1. So we have the gradient, we have the coordinate, put into the linear equation, we have y equals x plus pi and 2 plus 1. Notice that we leave it like that. The 2 terms pi and 2 plus 1 is our exact value for the y-intercept. Example 4, this time we're looking for the normal of the exact same question. So I'm going to cheat, and I know the coordinate at x equals that is going to be the same. The only thing different is the normal will have the gradient at minus 1 over that. So if this question was on its own, you would have to plug into the original equation to find y, and derive it first, find the derivative, and then do minus 1 over the derivative. But because we have it up there, we just copy paste it there. So minus 1 over 1 is just minus 1. Again, put into that format, it looks like that now. We have y1 as 1, x1 as pi and 2, and the gradient as minus 1. And we can simplify that to see that we have y equals minus x plus the same y-intercept. And if you look at these two, they will be perpendicular to each other, like we expected it to be, tangent and normal. Next example, find the equation of the tangent to y equals x log e x, where x equals e. So when x equals e, putting e into here, what do we obtain for the y value? Well, log e is just 1, so the y value will be e. So the coordinates will be e. Then the derivative, well, we have x times log e x. So we'll have to use the product rule. So log e x plus 1, because we derive the first 1 times the second log e x plus derive the second times x. So 1 over x is the derivative of log e x times x gives us 1. So if you've forgotten how to do that, have a look at deriving exponentials and logs and have a look at the product rule. I'm going to repeat it one more time. So the first part is derive x to get 1 times log e x. And then the second part is derive log e x to get 1 over x times x. 1 over x times x is 1. Okay, the derivative of that at e, at that point, is log e plus 1. Log e is just 1, so 1 plus 1 is 2. So we have the gradient, we have a point, put into the equation, and then simplify to obtain y equals 2x minus e. 2 times minus e is minus 2e, then bring the e over the other side, we have plus e, so minus 2e plus e becomes minus e. Okay, find the equation of the normal. So the same question, but now the normal. It's going to be exactly the same as the pattern from question 4, where I'm going to steal the coordinates instead of doing it again, and the gradient will be minus 1 over 2. But if the question wasn't standalone, again, you'll have to include this section of the working out down here. So same point, gradient is minus 1 over 2. So you have to derive it, get 2, and then do minus 1 over that, which is minus half. And now we're going to put it into the same format equation, y minus e minus a half, well, gradient x minus e, and we should get the same equation, but perpendicular gradients. Oops. And for the normal question, it's going to be a little bit like question 4. So if this was a standalone question, you'll have to redo finding the y-intercept, finding the derivative, and then doing 1 over that times negative 1 for the gradient. But because we've had the same question just above, I'm going to steal the y coordinate from there to get the point, and the gradient will be minus 1 over that, which is minus a half. Then we're going to do y minus y1 times gradient x minus x1, and then we have minus a half times x is minus half x, and then minus is plus half an e, plus an extra e is 3e over 2. Example 7, the tangent to the curve with equation x squared minus log e x at the point, that's an x value, that's a y value, passes through the origin. So we have a coordinate, the origin. Find the value of a. So here we have the graph in red, and we're looking for a point a squared minus log e a, where this value of a will make a line that goes through the origin. So a tangent to the red line looks like this. So I'm just going from this point here. These are all tangents. And at some point, this line, the tangent, will go through the origin. So this is the line we're looking for. So what value of a would that be? So we know that goes through the origin, so we have a coordinate, and now we have to find the gradient. So the gradient of the graph will be y2 minus y1 over x2 minus x1. So y2 minus y1, x2 minus x1. Now another way to find the gradient is to find the derivative. So 2x and minus the derivative log e x is 1 over x. I've also simplified by getting rid of the zeros there. Now these two are the gradients, so what can you do? Well, we have to find the gradient at A, and then we can equate them. So when the derivative is that, at A will be 2A minus 1 over A. So this equals to that. And the quickest way to do this is to CAS solve, and this will give us A equals 1. So let's do that using our CAS. So we go to main, so CAS solving that, let's substitute A as X so it's easier to type. So solve, so we have 2x minus 1 over x equals, so that's one equation. The other equation is, I'm going to do shift divide just so it's easier. So x at the bottom for A, this is the equation, this equation here I'm writing now. So A squared minus, in keyboard you'll find log E, oops, hang on, that's the wrong one. Log E is ln over here. And we have A, so x. Okay, solve for, well, we want to solve for x, comma x, enter. And we have x equals 1, so A is 1. Put my CAS away. And we can see from the graph that it's true. When A is 1, see, 1 for our x value. And if you put 1 in there, you're also going to get 1. 1 squared minus log E 1. So the CAS gives x equals 1 or A equals 1. And we can see from the graph that's true. X value here, or A, equals 1. Here's a summary of all the buttons you should have memorized by now from last year to calculate a line, tangent, and a normal. There's a shortcut using interactive calculation line. So you type in your expression, and then typing these two will give you the equation of line, or you can do it in graph and tab. You can pause the video and try using your CAS with these instructions. With the CAS, you can do find the tangent line and the normal line in the main function by writing the equation first, typing interactive calculation line and tapping on one of those. It will ask you at what point and what the variable is. Or you can use the graph function, and once you sketch it, you can type in the x value, just type in a number and a window will pop up. It will ask you at what point did you find the tangent or the normal, and then you'll type in the x value and it will give you the equation once you hit enter over there. So the instructions are there. Hit pause and follow the instructions. Make sure you are very, very fluent with how to type on the CAS. You'll need this quite a bit in the exam. Thanks for watching. I'll see you next time. Bye.